Physics I always wanted to do, and I'd intended to become a nuclear physicist, or maybe solid state physicist. And so I did a first degree in, actually it was chemical physics with French. And I moved back to England and started a PhD in physics at Cambridge University in the Cambridge laboratory, and I hated it. Not because of physics, but the project was wrong, the supervisor was wrong, everything was wrong. After 3 months, the happiest 3 months of my life, I switched. But I had a grant which was attached to me as opposed to being attached to the project. And so I thought, well, you've got 2 years and 9 months left. You can go and get a job, or you can go and do something interesting. What about astrophysics? And that's really why I started astrophysics. It wasn't a plan. Wow. Well, actually, right now is a highlight, funnily enough, because, well, in terms of research anyway, because we've got a really interesting result, and it's, if it's right, it's certainly going to change physics. And that is that the strength of electromagnetism seems to be changing across the universe, spatially, and that's pretty radical. So I would say right now is a really interesting time, because we've got a statistically significant result, and we've got the prospect of checking it using independent methods. My first university was called the University of Surrey, which is quite a relatively small university in Guildford, near Guildford, in Guildford actually, in one of the counties near London. And then PhD was Cambridge University. For my PhD, I worked on data from the Anglo-Australian telescope out at Coonabarabran. I made the mistake of following an Australian girlfriend. 20 years. 20 years ago I came here. 20 years ago this year. Okay. I would normally teach maybe 10 hours a week, and the rest of the time is research and administration. So there's a lot of research. My work is, it sits on the border between physics and astrophysics. Specifically what I do, there's a particular topic that I'm interested in right at the moment, and it's whether or not the laws of nature vary with either position in the universe or with time. Using spectroscopy of quasars. So quasars are very, very distant objects. You can see them out to look-back times of maybe 12 or 13 billion years. Age of the universe about 13.7 billion years, so you can see an awful long way back. And you can, with the biggest telescopes today, like the Keck telescope and the European Southern Observatory VLT, you can get absolutely fantastic spectra of these things. And it takes time. It probably costs, I don't know, $50,000 a night to run one of these telescopes. First paper was actually published in '99, first 2 papers, so that was pretty quick. We had a bit of a help because I got the data that I got was ready to work on. We didn't need to calibrate it from scratch. Then we had a gap, 99 up to 2001, so there was another 2 years. Published quite a few papers in 2001, a bunch of papers in 2003, a couple of papers in 2004, and then there was a big gap, 2004 to 2010. 4 years whilst we analysed a really large sample of data from the VLT, which is the Very Large Telescope, very imaginatively called in Chile, in northern Chile, but it's one of the world's best telescopes. So it took us all that time to analyse the data from scratch, do the measurements, and write the paper. In the 90s, I worked on Hubble Space Telescope data, and I got lots of time myself on Hubble Space Telescope. That was pretty good. And it was also very good because we ended up competing with what we were doing with our project with a very senior group of people attached to the Hubble Space Telescope on the same project. We ended up competing, some colleagues and I, and beating them, and quite comprehensively. And having my life threatened was another highlight in my career because of that, because of the success in beating somebody else to a project. But Statistically, the chances of getting funded for the normal grant, which is called Discovery Project grant, is about 1 in 5. Well, once you've done 3 years, you have the choice of going into honours. If you do well enough, you'll get credit average, I think, in the 3rd year. You can go into honours, the honours year, and in the honours year you can either do the 1 full year of honours, where you can do 2 6-month projects or 1 full year project, or, and people are doing this increasingly now, you can do an MPhil, which is an 18-month project where you do some coursework, but it's more research, and then you spend 18 months and you come out with a master's rather than the undergraduate degree.